Hello, everyone. Thank you for joining us again in this series on optics. We're working with mirrors, specifically in this series, convex mirrors. We did an intro video on convex and concave mirror terminology and sign convention, which I suggest you watch before you dig into this. This video will analyze image of an object outside. There's no outside, inside a focal length in the convex case. You'll see why. So we'll just analyze the image of an object as produced by a convex mirror, and then we'll work out some exercises. So again, please like, subscribe, comment, and share this video if you find it helpful. So let's begin. So just a quick recap. This is the convex mirror. This is the dark side. We denote it by dashes like this. So light doesn't enter here. It comes from this side and bounces back off this side. Again, a good example of a convex mirror is just a Christmas ornament. Okay, that's a very good example. The focal length, which is half the radius, this is the center. This comes from a sphere. There's the center of the sphere. There's the radius, and the focal length, which is half of that, are on the dark side of the mirror. Okay, so object here, shine light like this, they bounce back. Nothing enters here. This is the dark side. Okay, and here F and R are less than 0. They're negative. All right, so let's do ray tracing for a convex mirror. Okay, so the first ray is a ray coming in parallel to the optical axis. There's the optical axis. Is reflected as if it's coming from the focal point. So it's gonna be come in. Let's see it right here. Here's a ray parallel to the optical axis. It's gonna get bounced back as if it's coming from the focal point. It cannot go through the focal point. That's why we don't. We cannot say it's gonna come on this side. The focal point's on this side, so it's not gonna go through it. So it's gonna bounce back as if it's coming from it. So there it is. There's the ray that it's gonna follow. It's gonna bounce back like this. So it comes in, bounces back, and bounces back as if it came from the focal point. The green one is perpendicular to the lens, just reflects itself, or to the mirror in this case. So coming in perpendicular, as if it's going through the radius, right? Okay, the radius of a circle is perpendicular to the circle, and then it just bounces back on itself. And a ray through the focal point. So now we're gonna shoot a ray through the focal point, but it's not gonna make it. It's gonna be interrupted by the mirror. So again, it's as if it's coming through the focal point. It's gonna get interrupted. It bounces back parallel. Okay, and then obviously the reflected rays don't meet on this side. So we need to take this back, and then the green one is already there, and the blue one's already there. Those are the bounced rays, and they meet at this point right here. There's our object. Sorry, our image. Okay, so let's see what we have right here. Let's see if we can use the lens equation for this. So the object distance is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So DO in this case, and then the focal length is 1, 2, 3, 4, 5, 6. So F is -6 units, right? It's 5. It's -5 units. Because it's a convex mirror. We have the height of the object to be 2 units. And the height of the image, maybe half a unit. And the sorry, it's not negative, it's positive. It's pointing up. Okay. And again, these are the results. And it looks like 1, 2, 3.5, maybe d sub I is 3.5 units. And it's a negative because it's on the other side of the mirror. Again, this was all talked about in the introductory video for concave and convex mirrors. Okay. So let's look at the lens equation. Again, I put here thin lens equation in quotation because it's the same equation used for this mirror and for the lens. So 1 over f is 1 over, let me write it differently. 1 over di plus 1 over do is 1 over f. Bring do over, 1 over di is 1 over f minus 1 over do. So get a common denominator. And di, after we flip, let's plug in right here. di, f was -5. do is 12. do is 12 minus -5. Okay? So this is -5 times 12. And this is 17. Okay? So this is like -60 over 17. We cannot simplify top and bottom because the bottom is 17. It's very hard to simplify with that. So 60 divided by 17, that gives me 3.529, or roughly -3.53 units. And this is what we got for di from here. Roughly, again, it sat around 3.5. Good. Now let's look at the magnification. So m is -di over do, and which is also hi over ho. So let's first get the magnification, then get hi. So m is negative, di is -60 over 17 over do, which is 12. The 60 and the 12 give us a 5, and then the minus is canceled out, so that's 5 over 17. Okay? Magnification is 5 and positive because the image is upright. Okay? So 5 over 17 is roughly 0.3. That's not the height, that's the magnification. So now hi over ho is the magnification, which is 0.3. So hi is 0.3 ho. 0.3 times 2, roughly 0.6 units. And if you go up here, this looks like it's a half, maybe 0.6, closer to this line than that line. So we say we're in the ballpark. So this is a good, this is the analysis that's accurate. This is more or less an approximation or just a ballpark. Yeah, we did the problem correct. So we're on the right track over here. Let's do another one real quick. Again, the main thing is those rays are a little bit different than the lens and then the concave mirror, okay? So again, A ray coming in parallel to the optical axis, like this one, reflects as if it's coming from the focal point, and it bounces back. A ray perpendicular to the lens, supposed to be mirror right here, will go through the radius and bounce back on itself. That's what a perpendicular ray is. And then one that a ray through the focal point, again, it's going to get interrupted by the lens, but it's as if it's going through the focal point. Just make sure. I mean, you may not need this ray when you do the, if you're doing it by a ruler, as long as this tip, that tip are on the ruler. You draw a line, and you stop right here. Then you go and draw a parallel line like this. And they all meet over here. And we trace it back. The reflected rays, this, and that, when we trace them back, they meet over here. So for this problem, we have the DO is 1, 2, 3, 4, 5, 6 units. F is 1, 2, 3, 4, 5, 6 also. -6, because it is for a convex mirror. And H sub O is 2 units. So we observe that 1, 2, 3.5, roughly, H sub I is 3.5. And then D sub I, I'm sorry, that was D sub I, negative. And then it's almost 1. So H sub I, 90%, 4.9, maybe 1. Okay. Let's just see the lens equation, whether it gives us the same or not. So again, 1 over DI equal plus 1 over DO. Same algebra as before is going to give us DI F times DO over DO minus F. Okay? So DO is 6, F is -6. -6 times 6 over 6 minus -6. Do not be hasty over here and forget to take the negative of the negative. Otherwise, you get a 0 in the denominator, and DI will be at infinity, and that is not the case. Okay, so this is -6 times 6 over 6 minus 6, 6 plus 6, or 12. So D sub I is 36, -36 over 12, or -3. Okay, here we got 3.5. So the rays are maybe actually they met closer to here. Looks like they're meeting closer to here than there. And yeah, that's where they meet, over here. So maybe the ray tracing gave us 3.1, but it's not exactly at 3. But very close right here. I'm not sure why I pushed it out that way, but it's right here. All right, so that's the DI. Magnification now is minus DI over DO minus -3 over DO is 6. The negatives cancel. 3 over 6 is 1/2. So now that's the magnification. And the fact that it's positive, then it's a virtual image. And we know that it's a virtual image because it's a convex mirror. So now let's look at H sub I. So H sub I over H sub O is the magnification. Then so H sub I is H sub O times the magnification. 2 times 1/2, which is 1. So the height is 1, that means it's upright. It's plus, means it's upright. And it's almost 1. Maybe if we have moved it up here a little bit. Yeah, so we're in the ballpark. And that's how we do these problems. Again, the main thing is the ray tracing here is a little bit different than both the convex mirror, the converging and diverging lenses, all right? So in the next video, we're gonna do a lot of exercises. Okay, I'm gonna do 2 or 3 more, maybe a couple more videos, 2 or 3 in each video. All right, guys, thank you. Please comment, let us know what you think, and hope to see you in the next video. Bye.